Welcome. Dear student, we are discussing about the radioactivity. In previous lecture, we discussed about the activity of a radioactive substance. The activity of a radioactive substance is the rate of a disintegration of a radioactive nuclei, or the number of radioactive nuclei disintegrate per unit time is known as the activity of a radioactive substance. In previous lecture, we also discussed half-life, that is a time required by radioactive substance to disintegrate half of its original value. Friends, in this lecture, we have to see what is the specific activity. The activity of 1 gram of a radioactive substance is known as a specific activity. So activity of 1 gram of a radioactive substance is known as a specific activity. Activity of 1 gram of radioactive substance is known as specific activity. And therefore we can say that the specific activity AS, it is equal to activity of radioactive substance divided by M. Okay? And therefore the specific activity AS can be also written as we know that the activity of a radioactive substance, it is a lambda into N. So lambda into N divided by M. This is considered as the equation number 1. Okay. According to Avogadro's hypothesis, we can say that the 1 gram of a hydrogen atom, 1 gram of a hydrogen atom consists of 1 gram of hydrogen atom consists of 6.023 into 10 raised to 23 atom, okay, which is considered as Avogadro's number. Okay, so Avogadro's number N0, it is equal to 6.023 into 10 raised to 23. Okay, also we can say that the carbon 12 C12, carbon 12 or 12 gram of a carbon consists of 6.023 into 10 raised to 23 atoms, and therefore 1 gram of a carbon consists of here 6.023 into 10 raised to 23 divided by 12. So 1 gram of a carbon consists of 6.023 into 10 raised to 23 divided by 12 number of atom. Okay, so this is related to Avogadro's hypothesis. Now if we consider the m gram of a substance consists of, what are the number of atom in m gram of a substance? So m gram of substance, okay, number of atom in m gram of a substance, it is N is equal to N0 divided by atomic weight or simply molecular weight into M. Okay? M gram of a substance consists of these number of atoms. Okay? And therefore, we can say that N upon M, it is equal to N0 divided by atomic weight. Okay? Therefore, specific activity AS, it is equal to lambda into N divided by M. This equation became specific activity AS, it is equal to lambda into N upon M is a N0 divided by atomic weight. Okay, so this is a specific activity. Now, we know that the half-life of a radioactive substance, formula for half-life of a radioactive substance is T is equal to 0.693 divided by lambda, and therefore lambda is equal to 0.693 divided by capital T. Okay, therefore this equation became specific activity AS, it is equal to 0.693 into N0 divided by capital T into atomic weight. Okay, now when we solve this, okay, here N0 means Avogadro's number. So specific activity AS, it is equal to 0.693 into Avogadro's number is 6.023 into 10 raised to 23 divided by capital T, here divided by atomic weight. When we multiply 0.693 to 6.023, we get its value is 4.174. Okay, so we get 4.174 into 10 raised to 23 divided by T into atomic weight. This is a formula for specific activity. Now we have to find the mass of a substance for 1 curie of a substance. Mass of a substance for 1 curie of a substance. Again, we know that the number of radioactive atoms in m gram of a substance is N is equal to N0 divided by atomic weight into capital M. Okay, but activity A is equal to lambda into N. Okay, activity A is equal to lambda into N, and therefore we can say that activity A is equal to lambda into N. N means N0 divided by atomic weight into M. Okay, so this is the formula for activity. Okay, again lambda is a 0.693 divided by capital T. So we can write A is equal to 0.693 divided by capital T, where T is a half-life, into N0 divided by atomic weight into m. Okay, we have to find the mass of a substance for 1 curie of a substance. So here the activity is considered as 1 curie. 1 curie, it is equal to 3.72 into 10 raised to 10 disintegration per second per gram. Okay, so it is equal to 3.72 into 10 raised to 10 disintegration per second per gram. Okay, this is value of 1 curie, and therefore this can be also written as m is equal to, we have to find the mass of a 1 curie of a substance. It is m is equal to A into capital T into atomic weight divided by 0.693 into N0. Okay, so m is equal to here activity is a 3.72 into 10 raised to 10 into capital T into atomic weight divided by 0.693 into value of N0, that is Avogadro's number is a 6.023 into 10 raised to 23. Okay, and therefore this value is 8.864 into 10 raised to minus 14. Okay, this value is 8.864 into 10 raised to minus 14 into capital T into atomic weight. Okay, now if we consider a 1 curie source, that is activity of uranium-238. If we consider one example, uranium-238, the activity of this uranium-238 is 1 curie, and the half-life is about 4.5 into 10 raised to 9 years. Okay, here half-life is a 4.5 into 10 raised to 9 years. Okay, this is the half-life, and therefore the mass of a uranium which have activity 1 curie is 8.864 into 10 raised to minus 14 into atomic weight of the uranium is 238. Okay, into the half-life is 4.5 into 10 raised to 9 years, but this is in year, we have to convert it in a second. 1 year consists of 365 days. Okay, 1 day consists of 24 hours. 1 hour consists of 60 minutes. 1 minute consists of 60 seconds. Okay, so that here the mass of 1 curie activity a uranium substance is 3000 kg. 3000 kg. Okay. This indicates that 3000 kg uranium will have activity is equal to 1 curie. So this is related to specific activity and the 1 curie mass of a 1 curie activity substance. Okay. Again, specific activity means activity of a 1 gram of a radioactive substance is known as a specific activity, and therefore specific activity is equal to A divided by M, where A is a activity and M means the mass of a substance. This can be written as AS is equal to lambda into N, because activity is equal to lambda into N, okay, divided by M. This is considered as equation number 1. Now 1 gram of a hydrogen gas consists of 6.023 into 10 raised to 23 atoms, which is Avogadro's number. If we consider carbon 12, then the carbon 12 gram of carbon consists of 6.023 into 10 raised to 23 atoms, and therefore 1 gram of a carbon consists of 6.023 into 10 raised to 23 divided by 12 atoms, and therefore m gram of a radioactive substance consists of number of atom n is equal to n0 divided by atomic weight into m, and therefore n upon m is equal to n0 divided by atomic weight. But specific activity AS is equal to lambda into n divided by m, and therefore AS is equal to lambda into n0 divided by atomic weight. Here we know that the half-life T is equal to 0.693 divided by lambda, and therefore lambda is equal to 0.693 divided by T, and therefore specific activity is a 0.693 divided by capital T into n0 divided by atomic weight. Here n0 is Avogadro's number. Its value is 6.023 into 10 raised to 23. Okay. When we multiply these two numbers, we get 4.174 into 10 raised to 23 divided by T into atomic weight. Okay. So this is a formula for a specific activity. Now, if we have to find the mass of a substance for 1 curie radioactive substance. Okay. For that, again, if we consider m gram of a radioactive substance, then it consists of number of atoms n is equal to n0 divided by atomic weight into m. So we know that activity A is equal to lambda into n. So putting value of n, we get A is equal to lambda into n0 divided by atomic weight into m. Okay. Again, lambda is equal to 0.693 divided by capital T. We get this term. But one activity is considered as a 1 curie, and 1 curie is equal to 3.72 into 10 raised to 10 disintegration per second per gram. So we put here, okay. Now m is equal to A into capital T into atomic weight divided by 0.693 into n0. Again put value of Avogadro's number, okay. And when we calculate this, we get mass m is equal to 8.864 into 10 raised to minus 14 into capital T into atomic weight. Now, if we consider uranium, activity of a uranium is 1 curie. Okay, uranium 238, and the uranium activity of uranium is 1 curie, and its half life is 4.5 into 10 to 9 year, and therefore we put value of half life and atomic weight in this equation. We get m is equal to 3000 kg. It indicates that 3000 kg uranium will have activity equal to 1 curie. So this is related to specific activity. In next lecture we have to see partial radioactive decay. Thank you.